Bismillahirrahmanirrahim. Hi and Assalamualaikum. My name is Sakila Abdul Rahman. My metric number is CE190208, and today this is our last lab from section 4 group 3, exercise 9, AC voltage measurement using oscilloscope. And I'm going to present about exercise 1, activity 1. In activity 1 is about series R1 and variable resistor R1 connected with oscilloscope. And I'm going to show the output graph for VAC supply, VR1 and VVR1. And let me start. Here this is the sketch circuit in the multi-sim, as shown here. The VPK set to 14.6 VPK and the frequency set to 50 Hz. The R1 is set to 100 and R2 is set to maximum of 1K, 1 kilo ohm. And this is the oscilloscope. The channel 1 connected at the supply, incoming VAC supply. The positive connected to the incoming positive, negative connected to the negative incoming, and which is on the B, the positive connected to the positive of R1, and also the negative connected to the negative of R1. And here the second oscilloscope. The first oscilloscope going to control for VAC supply and the VR1. Meanwhile, on the second oscilloscope connected to the A channel connected to the VR1, variable resistor R1, VVR1 connected to the positive side and the negative side connected to the negative output. And we see for the first output of the oscilloscope, here the time base we set to 10 millisecond per div, and channel A set to 10 volt per div, and channel B set to 10 volt per div. Everything we set to the 10, and set to the AC channel, and set to single, so the circuit won't run. So on the first time frame 1, we set to the V peak, and the second time frame 2 we set to the negative side. Time frame 1 for positive side, and time frame 2 for negative side. On the time frame 1, the V peak for channel 1, actually the pink color is controlling the VAC supply, meanwhile the channel will be controlling for the VR1. So as you see here, the waveform of pink color is the VAC supply, meanwhile the blue color waveform is controlling the VR1. Okay, as we can see here, the V peak .6. As you can see, this is the reading for V peak for channel A, meanwhile on the channel B, the V peak is here. Then we see for the second oscilloscope is set also same. One let it tally to the V peak of positive side, meanwhile on the 2 time frame we let it be on the bottom negative side. So this is the V peak. To make it clear, we see on the output. Okay. Here, this is the output. of the graph VAC supply. The VAC supply I take here is from the here that I have paste here. The pink color is not very clear, right? So let me make it look clear. So I have sketched the output of the graph VAC supply. The VP is 14.418 and the time frame of I took is 10 V for div 10 volt per div. So in one cycle it take 10 volt div. So here once on the positive side is 5, on negative side is another 5. So 5 plus 5 is 10. So this is the calculation for VPK minus VPK. Here the VPK is set to 14.6 as shown in the lab sheet, and then minus by PK, VP 14.418, and it get 0.182 volt. The period is 0.02. Actually, the period is 1 over F, 1 over 50. It will get 0.02, and the frequency set to 50 Hz. And the VRMS is, the formula is 1 over 2 squared and times by VP. And here 1 over z squared times 14.418, and we will get 10.195. And here this is the VR1 graph. The VR1 graph, the VP is 1. Actually it is 1.311 here. I'm sorry, that's mistaken. Actually, the V peak is 13 1.311, but I mistaken by drawing it. Actually, I'm right in drawing, but wrong in entering the value. Actually, it will be 1.311. And 14.6 minus 1.311 became 13.289. 15.289. Here should be 1.11 and 1 over z squared times by V peak, and you will get 0.9201, 0.9270, sorry, 0.9270 volt.
For activity 2, we just need to adjust the VR1 to 200 ohm. So just select the component, basic, and find the variable resistor 200. So we adjust. So we need to 100%. So we need a oscilloscope and then do the connection. we can change the color of to white. For the R1, the wavelength, we can change it to green. So we try run. So we find the wavelength at the oscilloscope. So we adjust. So how to find the Y minimum, Y maximum? We just click this right to the mouse and sorry, Y minimum. Click right, Y maximum. So we find